All right, folks, welcome once again. Okay, so welcome to day four of our 15-day course, and this is Thursday, right? Thursday, we'll do a session today, and we'll do a session tomorrow, Friday, and then we'll meet on next Monday, right? So this is day four, and we're going to start module 3 today. And module 3 is mainly around storage services, right? So there's a bunch of storage services that we will talk about, 5 of them, and we'll also touch upon what is called the command line interface. The stuff that we've seen so far is the AWS Web Console, right? But we also need to learn about the AWS command line interface that can be used for automation of certain tasks. For example, you might want to upload something on AWS on a regular basis, right? Or you might want to take a snapshot of your EBS volumes on a regular basis. So those kinds of things can be automated, and for that, you need to know about the command line interface. All right, so this is where we are in the course, in the agenda, right? So we've done EC2 instances. This is one of these services under the compute category, right? There are other services that we've not talked about, and we've only focused on EC2, and you know, there's good reason for it. EC2 is the service that is easy to learn, right? These are basically virtual machines that you must have used before as well, right? And also the fact is that we all will use EC2 primarily, right? So most of our time will go into EC2 instances. So it's very important that you get started with EC2 and we spend enough time on that. Right, so we've done that. We'll talk about some of the other compute services a little later. So we'll talk about Lambda, Elastic Beanstalk, all those things are coming up, but in module 7 or 8. Okay, now it's time to spend now it's time to look at the storage category, because you know, after compute, storage is important when it comes to infrastructure, right? So any application, no matter what kind of application you have, you need both compute, which is servers essentially, and you also need storage, right? So both are required, and therefore our next you know, from a priority perspective, after compute, we always look at storage. Okay, now we look at 5 services here, and this is, you know, from experience, although you know, this is one module, we usually need more time. Okay, we usually need more time, so we'll probably spend today and as well as the whole of tomorrow on module 3 on storage. All right, and we'll talk. We'll start module 4 on Monday. Okay, let's do a quick review of module 2. Okay, and I know that some of you have looks like some of you have practiced, right? So you should be practicing your, you know, whatever we do in the class, right? And more. There are some labs available in the LMS, and you can also start experimenting with your own projects, right? You can for example do a proof of concept, but at the very least you should be practicing what we've done in the class. For example, you know, setting up a WordPress site on an EC2 instance, right? So you should be doing that because you know, we'll be going at a very rapid pace. As you know, this is a very sort of a you know, accelerated course, right? So you don't have much time between sessions, so it'll seem very fast, and I hope you'll be able to find some time outside of the class to do this, to do the practice. All right. Anyway, so let's do a quick review of module 2, right? And the objective of module 2 was to get you going with EC2. All right, which is very important because EC2, like I said, is the most important service, the most commonly used service. When you start using cloud, the first thing that you have to use is EC2 instances, right? And the idea was to see if you can get an application going, right? So set up a server, connect to it, install the dependencies, all the software that you need, maybe a web server, maybe a database server, right? And then deploy your application, understand IP addressing, so that you can point a domain to the IP address, and take a look at the application end to end, right? Can we get it functioning end to end on an EC2 instance, right? So that was the objective, the goal of this module. And as part of that, you know, exercise, to do that, we had to learn about some concepts, things like AMI, Amazon Machine Image. This is basically a template which can, which defines what software will be installed on the server that comes up, right? And the army can be anything. It can be an open source. It can be, first of all, an operating system, right? Linux, different flavors of Linux, or it could be Windows, different versions of Windows, different flavors of Windows as well, right? Or it could be something more than an operating system as well. So it could have some additional software like MySQL or Oracle databases, or it could have application servers like IBM WebSphere, and so on, right? Armies can also be the complete stack. So the army can also have a full application stack, right, including the end user application. Okay, and the software on armies can be commercial. These can be open source as well, right? And lastly, you can also create your own armies, right? So once you have a server set up fully and tested, you can convert, you can, from that server, one server, create an army, and then use that army over and over again, right, to create as many servers as you like. Okay, so army is a very important concept. You must understand this fully. We also looked at security groups, right? These are firewalls where by default all incoming requests are denied, are blocked, right? So you have to open up the firewall for specific protocols, ports, and to specific source IP addresses, right? So it is possible to open it up to everybody. Usually you do that for, say, the HTTP ports, right? But for SSH ports or for RDP ports, you should be careful and specify only your IP address or your IP address range. Okay, so this is very important. All right, and finally, from a security perspective, we also looked at key pairs. These are standard authentication mechanism in the Unix and Linux world, right? But we saw we can also use it with Windows instances in AWS, right? So these are much better than passwords. Okay, key pairs are superior to passwords in terms of security, right? And also they are as easy to use. So you should get familiar with the key pairs. And we also had a big discussion around how do we create users on the operating system, and how do we set up the key pairs for each user, right? Which is what you should be doing. Okay, so that's normal server administration, right? But what what you should be doing is, on your operating system, create individual user accounts for all the people in your team, right? Whoever has to access the server should have their own user accounts on the operating system, and then each user on the operating system must have their own key pair. All right. Okay. So these three, I think, are the most important things. The other important thing is also the IP addressing, right? So you must understand private, public, and elastic IP addresses, right? And always use private IP addresses for communication between servers on the cloud, right? So let's say you have an app server talking to a database server, both on the cloud, right? So you should always use the private IP address there. If you use the public IP address, you'll be in trouble, because the traffic will go out to the internet and come back into the server, which will slow your application, which will cost you in terms of traffic, network traffic, right? So be careful. Make sure that you understand these very well, and use IP addresses, private IP addresses for internal communication. All right. However, for communication between the internet and the server, right? So if you're connecting to the server from the outside, right, via the internet, you have to use a public IP address, okay? Because the internet does not know private IP addresses, right? So when you do that, when you connect via the internet, you have to use the public IP address. All right. However, the public IP address can change when the server restarts, right? So that's one problem with the public IP address, and for situations where you don't want that kind of change, right? And especially this is for DNS records, right? So when it comes to DNS records, you don't want the IP address to be changing, right? For other things like SSH connections, if the IP address changes, that's fine, right? One of you mentioned you're not able to connect because the IP address had changed, but that's not a big problem. Okay, the big problem is your DNS record is pointing to a public IP address, and then it's a ticking time bomb, like I mentioned yesterday, right? And you restart your server after maybe a patch or an update, and the IP address is gone, right? And your site is not working. So that's the big problem. And for those kinds of situations, right, you should use the elastic IP address instead of the public IP address. Okay, all right. So if you understand these things, you are in a good situation to start using EC2 instances in your projects. All right, and you should get going. You should get going with doing that as soon as possible. All right. Okay. So that's a review of module 2. Now let's talk about module 3. Okay, so here we are talking about storage, right? Storage, and we'll unlike the previous module, we'll have to talk about a bunch of services, right? So we look at especially we look at EBS, Elastic Block Store. We look at S3, Simple Storage Service, and then we'll spend most of our time on these two, okay? Because these two are far more important than the others. So EBS and S3. I think we'll spend 60–70% of the time in this module on these two services, right? Okay, and then we'll also talk about a few other services. So there's Glacier, which is by the way, EBS is like a hard disk, right? EBS is like a hard disk. The easiest way to think of EBS is to think of hard disks, and S3 is more a centralized storage, right? And it's you can sort of read and write from S3 over HTTP protocols. Okay, so it's a different kind of storage. S3 it's mainly used for things like, say, video files, storing your video files, audio files, image files, and other static content like CSS, JavaScript, and so on. Okay, so it's a different kind of storage from EBS, and then we have Glacier, which is very cheap, right? The cost of Glacier is very low, and you can use it for a long-term archival. So anything that you need to store for a long time, right? You're normally looking for something cheap, because the amount of data becomes very large over time, right? So Glacier is basically for long-term archival types of use cases. Okay, all right, and then we have a couple of other options here: Snowball and Storage Gateway. These are more for enterprise use cases, right? So some of these services are more for larger companies. All right, when I say enterprises, I usually mean larger companies, right? Although even medium-sized, smaller companies can also be called enterprises. But if you're a large company, then these services like Storage Gateway, Snowball, these are more important. Okay, we'll talk about this. I'll explain that. Okay, we'll also, like I said, we'll also talk about command line interface. Right, this is required. The command line interface has many use cases, especially for system administrators who want to automate certain things. Right, so you might want to write a shell script, or a PowerShell script, or a Perl script, right, to automate things like taking regular snapshots of your EBS instances or your RDS instances, right? And for that, you need to have some API, right? And that API is basically the command line interface. Okay, so we'll take a look at this in addition to using the web console, right? We have seen the web console thus far in the course. Today we'll look at the web console, but also at the command line interface. All right. Okay. So this is the agenda, and so we're talking about 5 services and the command line interface, and most of our time will go into EBS and Amazon S3. Okay. And before that, we'll also talk. Before we get into these services, we'll talk about traditional storage, right? How things used to be before the cloud. Especially in the larger enterprises, right? And what are the problems with traditional storage, and now what is cloud, right? How are these services on the cloud different, and how are they better? Okay, so it's storage on the cloud is much better, and we'll try and understand how that is, right? Why it is better. Okay, and then once we've had this introductory discussion, we'll then get into these 5 services. All right. Okay. So let's begin. Let's talk about traditional storage first. All right. Let me skip this. Let's start here. Okay. Let's start here. Okay. So this is a very important slide, right? I think you should try and remember this pyramid, right? We'll keep using this pyramid throughout this module. To understand the other services, right? The 5 services that we spoke about, and also maybe throughout the course as well. Sometimes this pyramid will come up. Okay, so the pyramid describes the needs from a storage perspective, the needs of a typical organization or a company. Okay, so the first thing that you need to understand here is that storage is not, it's not just storage, right? Storage is there's a need for different kinds of storage. All right, so it's not like one monolithic type of need, right? There are different needs when it comes to storage, and those needs can be described in this pyramid fashion. All right, and you can see the pyramid has four tiers. Tier 0 right at the top, and then 1, 2, and 3, 3 being at the bottom. All right, and the shape is a pyramid because tier 3 is where you have a large quantity of data. All right, and tier 0 on the top is small, right? In terms of volume, it's small because that's the data which is most active. Okay, so the way to look at this pyramid is to think that the stuff at the top is the most active, right? The most active, the most recent data, and then as you go lower down the pyramid, right, the data becomes older, okay, or colder, right? In the storage world, you also have this term cold, right? Cold data is basically old data, which is not, frequently used, right, or frequently accessed. Okay, so it has to be stored safely, but it's not frequently accessed, right? So that data is cold data. So what you have is you have hot data or active data on the top, and then as you go lower down the tiers, the data becomes older and older, and the older it gets, it becomes less and less accessed. Okay, that's the nature of data, right? And also you can see, as it becomes older, the amount of data becomes more and more because it accumulates, right? It accumulates over time. Okay, so this is a very important concept, and the main thing to understand is we have different storage needs, right? It's not just one type of need. There are different storage needs that an organization has, right? And now we're talking before the cloud, right? So what the industry has done, the IT industry, the storage industry, what they've done is they've offered different solutions for these different needs, right? And for example, for tier 0, where we have active data, right? And these are typically databases. Let's say, relational database like Oracle or Microsoft SQL Server, right? So you have active data, and this storage needs to be fast as well. Okay, databases need to work very fast, so the storage equipment has to be fast enough, right? So what we use in tier 0 is, like it says here on the slide, we use SSD, solid state devices, right? So these are faster equipment, right? And it's faster technology basically, and also it's more expensive. Okay, it's more expensive. Okay, so now if you go to tier 1, this is slightly older data, right? It's slightly older data, and here it's still active, right? It's still active. It's still accessed by the organization or by its customers, but we don't need the same level of performance, right? So we are okay with a lower performance in return for lower cost. Okay, so tier 1 equipment is usually cheaper, right, but not as good or not as fast as solid state type of equipment. Okay, so you can see here there's 10,000 RPM, right? These are revolutions or rotations per minute, and HDD. HDD is a traditional storage, right? The traditional, the one with the spindle where the hard disk rotates around the spindle, right? So that kind of thing. And these are cheaper, but not as good or fast as SSD. Okay, so that's tier 1. And then if you come one tier below, tier 2 is now becoming, cold data, right? So this data is not very frequently accessed. Okay, so we are okay with something even slower, right? Even slower, but cost starts to become a concern, right? Because the amount of data is becoming large, and we don't want to spend too much because anyways we're not accessing this data too frequently, right? We need it to be safe. Okay, so for example, think of a bank, right? A bank has to keep the data, the records safely, right? For many years. So normally a bank will keep data for 7 years. And nowadays, it's possible to keep data for much longer as well, right? But normally a banking regulator, right? The regulator is the one that issues the license and to the banks to function, right, and to exist. So the regulator, whatever the regulator says, you have to comply. So in India, you have the Reserve Bank of India, right? That's the regulator for banks. In the US, you have the Federal Reserve, right? So the regulators have issue regulations, and on the storage side, they'll probably say something like, okay, all banks, you have to keep your data safe, very safe, right, for 7 years or 10 years or even more. Nowadays, storage is so cheap that they can easily store data for much longer. Okay, and the whole idea is you need to store data because it may be needed, right? It may be needed later. For example, there could be a tax case, or there could be some kind of a major crime, right? So you have to go back, say 5 years, 4 years, and look at your records. And if the regulator or the law enforcement authorities they ask for some data, the bank better have the data, right? They can't say no, we lost it, or we didn't store it properly, right? So those kinds of needs are there in all companies. So the data has to be safe. Okay, the data has to be safe, but it's rarely accessed, right? So how many police cases are you going to have? Like in the case of a bank, it's very rare that data is actually required, but it has to be safely kept. Okay, so for banks, this is a regulatory overhead, right? They don't make money from this. They don't make profits on this, right? So they want to do it at low cost, right? But at the same time, they want to comply with the regulations. So those kinds of needs are there as you go down the tiers, right? So tier 2, tier 3 is where you're looking for something cheaper, right? You don't care about performance because the data is not accessed too frequently, right? But you care about safety, right? It has to be safe, and also you care about cost. It should not be expensive. Okay, so that's what happens in tier 2 and 3. You have cheaper technologies, all right, but hopefully safe enough. Okay, and that's how it works. Okay, so the first 2 tiers are the term used for these kinds of storage equipment is volumes, right? So you have an EBS volume or a hard disk volume, and the bottom 2 tiers, tiers 2 and 3, the term that we use for this type of storage is vault. Okay, so volume implies active data, and vault implies inactive data. Okay, so yeah, so try and remember this pyramid because we'll keep referring to this throughout this module. Okay, now let's talk about some of the problems that people used to face, in traditional storage before the cloud, right? Before the cloud, and even now, right? Not everybody has moved to the cloud. In fact, most of the world is probably not yet on the cloud, right? But they're moving. They're moving, and this will play out. We'll probably have data centers and hybrid data centers for a long time, right? But what are the disadvantages of traditional storage, right? So this was becoming apparent right earlier, and let's just look at the first two, right? The first 2 points here. And for example, the first point says that 40% of storage that is purchased is not used. Okay, it's not used, and this, it's not just on the storage side. This problem has been there on the server side as well. Okay, because what happens with traditional equipment is that you don't have the same flexibility as cloud, right? So if you don't want something, you can't give it back, right? And also the purchasing cycle is typically longer because you have to request for proposals, receive quotations, right? Negotiation. So normally the purchase cycle is not efficient as well, right? It takes time to place an order and get it fulfilled. Okay, so because of these reasons, people always used to buy more than what was required, right? And since there was no way of knowing how much was exactly required, people would try and be very safe and add and order much more than they would end up requiring, right? So this is a common. I mean, it's not surprising at all that you buy some equipment and then you hardly use it. Okay, so in fact, in the case of servers, I think there are some studies which show that server utilization used to be at some point 5%. Right? So you buy so much that you hardly use 5% of your capacity. Okay, so this used to happen before the cloud, and this is a big problem because your capital is locked up. Right, you paid a lot of money, the money is gone. Right, that money could have been used for something else. Right, maybe marketing, maybe product development, but you've locked up that money in equipment which you're not even using. Okay, this was one problem. Now the second point here that you can see on the slide is that 95% of data that is stored in expensive storage right, like SSD, is actually cold, right? So the data is very old. You don't use it, you don't access it, nobody looks at it, right? But it is still occupying expensive storage, right? So this is another problem that was noticed in the industry. Okay, and so on and so on. All right. Now if you use cloud storage, right? This is some study by IBM, and they've shown that if you combined existing storage with cloud, right, you can sort of in a hybrid environment, you can cut the storage cost by half, right? So you can see, I mean, the idea here of showing you this slide is to understand that cloud storage can save you money, right? It can save you money, and it's also much better in many other aspects. Okay, so let's see what those aspects are. Let's try and understand cloud storage now. Okay, so cloud is storage is basically what happens is, first of all, you don't worry about the hardware, right? You're not buying anything, you're not maintaining, you're not upgrading, right? You're not doing anything of that sort, and everything is done by AWS for you, right? You don't even know where the data centers are. You don't look at the equipment at all, right? So you're not involved in the hardware side, which is pretty good actually, right? If you're say a bank, why should you get involved with hardware, right? It's not your expertise, it's not your core competence, right? So one major headache is out of your hands, right? It's in the hands of someone who's more competent, right, to do it, and also they're doing it at a large scale, so you get some cost benefits, etc. Right? So on the cloud, you have a fully managed cloud service from a hardware infrastructure perspective. All right. Okay. The other thing is that you don't have to worry about backups in many cases. Okay, we'll talk about each service independently, but what AWS does, for example, is it automatically backs up your data. Okay, so S3, for example, right? S3 is backed up multiple times. If you store something in S3, that object is backed up multiple times. Multiple copies are created in multiple availability zones, right, throughout the region. Okay, and they do it so many times, the copies I mean, that the data durability of an object in S3 is extremely high. Okay, so in S3 you have 11 nines durability, which means what it means is 99.99%, right? That's the sort of data durability, which means effectively what that means is your data, once it is stored in S3, will never be lost. Okay, there's a very, very tiny chance of loss. Okay, it's virtually zero. Okay, chance of loss is virtually zero, and that's the kind of durability that is possible because AWS does lots of activities to ensure that your data is safe, right? And all of this is transparent to you. All of this is automated. You don't have to worry about it, right? All of it is done automatically. Okay, all right. Another advantage of cloud is that it's available over the network, right? As long as you have an internet connection, you can access your storage anywhere. Right, so let's say you're a company, you have many offices, right? So you can access your data from anywhere, right? You're a multinational company with offices in multiple countries, right? It doesn't matter. You can access your storage from as long as you can connect to the internet, right? Now imagine having some storage in your Delhi office, right? In a certain city, you have some storage. How will you make that available to other people throughout your company in other offices, right? So those kinds of issues are gone because now it's network-based access. All right. Okay. Now the other benefit. This is how it is. This is about how it is managed and how you access it, right? And how it is more durable. Now on the payment side, on the payment side, right? It's pay per use, right? So you only pay for what you use. So if you store 1 GB of data, you only pay for 1 GB, right? And if you store 1 TB of data, you pay for 1 TB. Right, and you can scale up. So tomorrow you may store 5 TB, so you pay more once you start using more, right? And this is also very, very good, by the way, okay? Because in the past, what used to happen is you had to pay upfront, right? Thousands of dollars upfront, right? You pay, and then you may not use that equipment at all for the first few months, let us say, right? Then you start using it slowly for the next 6 months, and then next year you may start using it to a fuller extent, right? So those kind of things, or you may never end up using much of that storage equipment at all, right? But the payment is upfront, right? You've already paid, and now you're suffering the consequences of not using it, right? But that's not the case here. If you don't use anything, if you don't use storage, right, you don't pay. You don't pay. All right. Also, you may be using storage, but then you decide you don't need to. You can delete the data, and then there's no further payment, right? So you can also give away your storage capacity, right? So it's all very flexible, pay per use, pay as you go, right? And there's lots of opportunities for cost optimization. Okay, so I hope you're getting a sense how cloud storage is better than traditional storage. All right. Okay. Shyam, you're saying voice is breaking. Okay. So on my side it looks fine. Okay. On my side it looks fine because I have this. I can check the quality of the voice. So it looks fine on my side, and I don't see others complaining. Okay. So it looks like it's on your side. Okay. So I hope it's fine for you now. Let me know. Okay, I've just sent a message to Shyam. Okay, James, you're saying it's definitely breaking, but audible. Oh, okay. Okay, how about others? How about others? All right. Okay, so it looks like a couple of you are saying, but some of you are also saying it's fine. Yeah. So yeah, Vivek. Yeah. So I think if it persists, right? So what I suggest is you can exit the webinar and rejoin. Maybe that will help. Okay. My indicator. I have a indicator here which seems to say everything is fine on my side. All right. So let's see. Okay. All right. So this is cloud storage. All right. And now let's talk about the storage options available. Let's introduce. Right. Let's look at some of the options available on the cloud. Right. And for example, the two major ones are EBS, Elastic Block Store. Right. And the second one is S3, Simple Storage Service. Okay. So EBS and S3 are the two big ones. And EBS is basically what is called block storage, right? And it behaves very much like a hard disk drive. Okay, so it's like a hard disk volume, and EBS is used with EC2 instances. You attach an EBS volume to an EC2 instance, right? And then the EBS volume behaves like a hard disk. And let's say you have a database on your EC2 instance, right? The data in your database will be stored in the EBS volume. Okay, so that's one option, and the other option is S3, Simple Storage Service, and this is different. Okay, this is a different kind of service. These are not competing services, right? They are complementary, and they occupy different positions in the pyramid that we looked at. Okay, so EBS sits in the tier 0, sometimes tier 1, and S3 would be in tier 1 or tier 2. Okay, and S3 is also called object storage. It's a different type of storage, object storage, and it's mainly used for it's not attached. S3 is not attached to an EC2 instance, right? It's a more centralized storage, and you can access it from multiple servers. The user can also directly access objects in an S3 bucket. Okay, and it's normally used for things like videos, images, maybe audio files. Static stuff, static stuff like say CSS files and so on. Okay, that's one use case. It can also be used for anything really. Okay, so you can store things like database backup files. You can also store archival files in S3. Okay, so anything can be stored, but it's not as fast, right? It's not as fast as EBS, so it can't be used for say databases, right? And it is not attached to a server. You have to connect to S3 over HTTP. Okay, so these two are different types of storage, right? And you have to sort of pay attention to what the differences are, where to use which one. Okay, that's important to understand. All right, and they are not competing services, although they may compete. There may be some overlap sometimes, right? But in general, they're not competing services, and you will normally end up using both. Okay, you'll end up using both in your stacks. All right. Now there's something called Glacier, right? The third service that we talk about is Glacier. This is a very cheap option. Okay, it's very low cost, and Glacier is actually used in the last tier 3. Okay, so it's so cheap that you would use it for tier 3, which means it's basically a replacement for a tape drive type of options. Okay, and Glacier actually is a class within S3. Okay, so S3 is a bigger service, and Glacier is an option, it's a storage class within S3. Okay, so in that sense, Glacier is also an object storage, but it has certain different performance characteristics to the standard S3. All right. Okay. So now comparing these three services to the pyramid that we looked at, right? So EBS sits in tier 0. Some EBS volume types can sit in tier 1. Right? So tier 0 is the fastest. Tier 1 is still fast, but slower, right? So there are multiple volume types in EBS, and some of them sit in tier 0, some of them sit in tier 1. Okay, S3 would sit in tier 2. Okay, it's not as fast. It's not as fast. It has other powerful capabilities like high durability, high scalability, right? But it's not as fast as EBS. So you would not use it with your for your databases and such. You would use it for things like video files, etc. All right. And Glacier is a class within S3, but it specializes in being low cost. Okay, it's a low cost option within S3, and therefore you would use Glacier for tier 3, right? Which is basically where normally you would use tape drives. Okay, so we have three services, right, which meet three different types of needs. Okay, so we may end up, right, you may end up using all three. Right, normally you use EBS and S3 for sure, and of course Glacier can be used for long-term storage, long-term archival as well. Okay, so all three will probably be used at some point in your stacks. Okay, now let's touch upon, we're still, we're looking, this is just an introduction to these services, right? And then we'll go into each service in detail. But let's touch upon the other two services as well in the agenda for this module. And these two services are Storage Gateway and Snowball, right? More relevant for enterprises, right? Larger companies. And what these are is Storage Gateway is actually a gateway. Okay, it's not a storage service. It doesn't offer storage on its own. It's a gateway to storage on the cloud, right? So let's say you have a hybrid cloud environment, right? So you have some servers on premises, right, in your own server rooms, in your own data centers, right? And you want to combine your existing infrastructure with storage in the cloud, right? So what you can do is you can use this gateway service. It's basically an appliance, a software appliance that you install on a server in your server room or data center, right? And this gateway can plug into your existing IT environments with no change, okay? Because it supports existing protocols like ISKC or NFS. Okay, so it supports existing protocols, so it can plug into your on-premises environment seamlessly without any changes, right? And then when you save something, right, instead of getting saved in the local equipment, the object or file will get saved in the cloud in S3 or Glacier or as EBS snapshots. Okay, so it's a service which lets you use cloud storage in a simple manner from your existing infrastructure. Okay, so that's what a gateway is. And then we have another service called Snowball. This is actually a physical device. Okay, imagine a snowball, right? Someone makes a snowball and throws it at someone else, right? So it's a physical device which is shipped, which is couriered, right, between your network or your data center, your offices, and AWS data centers. Okay, so it's a physical device, a storage device, but physical, which moves, actually moves, right? We're not using the network here. We're actually using a storage device to transfer data from your data centers to the cloud. Okay, and the device is used normally because you may have a large amount of data, right? And to transfer that large amount of data, it may take too much time if you were to use the network, right? Also, the cost of transfer over the network may be too high. Okay, so in those types of situations, it makes sense to use physical device. Just you have to request for the device to be sent to you, and you can load it up with a lot of data and then send it back to AWS, who will then download your data into the cloud storage options like S3. Okay, so these are some additional services that are available. All right. Okay. Okay. So now let me stop here briefly. Right? Let me briefly stop here. Let's see if you have any questions. Remember, we're using the mod 3, right? This sheet, a third sheet. Let's use this one. Let me know if you have any questions on what we have discussed so far. Okay, by the way, I hope the audio is better, right? If not, please let me know. All right, so let me look at this question. So, Babita, what you're saying is traditional versus cloud, 95% of data is cold, but whether you are in cloud or traditional, you will store this data, right? Okay, so that's point number one in your question, right? 95% of data, and this is in traditional, right? Traditional storage. The idea was 95% of data stored in expensive storage, right? Expensive storage. Uh, is actually cold. Okay, that's what we were saying, right? Is actually cold. So what happens in the cloud is you can easily move. You can easily, because we'll see this. I'm going to show you a demonstration in this module where you will see how easy it is to move data from one storage type to another. Okay, so that's the benefit of cloud. You're right. The problem doesn't go away immediately, right? But on the cloud, it is easier. Okay, on the cloud, it is easier. Okay, so the cloud, what happens is you have easy access to different kinds of storage, right? All the four tiers, right? And you can easily set up rules which will automate movement of data between tiers. Okay, so we'll see how it is easy. First thing on the cloud is you have access easily, right? So in traditional, for example, you may be storing 95% of data in expensive storage because you don't have cheaper storage, right? That may be one problem. And even if you had cheaper storage, there was no easy way, right? There was no automation, there was no easy way, maybe, right? Or you never got around to doing it. So those kinds of issues may have been there, right? But in the cloud, it's much simpler. First of all, access is available, right? Access is available. It's pay as you go, right? You don't have to pay front for getting different types of storage, right? And then it's also easy to automate the movement. Okay, so we'll see that. We'll see that. Okay, the second part of the question is on the gateway, the storage gateway, and this is basically, it's used in hybrid environments. Let's say, okay, hybrid environment. So let's say you're a company that has existing data centers, existing server rooms, right? You're not going to throw that away, right? You may want to move to the cloud, but you have existing investment, so you have to use your existing infrastructure, right? But then a lot of people want to look at cloud as something that they can extend into, right? So if you have a hybrid, if you have a on-premises infrastructure, you can extend your storage to the cloud, right? Because cloud is more flexible, right? It may be cheaper. You have pay-as-you-go pricing, right? So instead of buying new equipment when you need more storage, right, you can simply use your existing infrastructure and extend your storage into the cloud, right? So this makes sense. This makes sense, right? So because you can't throw away everything and move to the cloud wholesale, right? But at least you can sort of start using cloud for say some extra storage that you may need, or some temporary storage that you might need, right? So you can do that. So in these cases, what happens is the gateway becomes the gateway supports protocols, right? Existing protocols. Example, IceKC. You might have heard of IceKC, or you might have heard of NFS actually, right? So what happens is it supports these protocols, and therefore you can easily plug in the gateway in your existing infrastructure, right? In your existing infrastructure. So what happens is your existing tools, right? Your existing tools, example backup tool, okay? Example, a backup tool can still be used. No change required, right? No change required. The difference is with the gateway, the data will be stored in the cloud, right? So it'll work as if nothing has changed, but actually the data, instead of being saved locally, is being saved in the cloud. Okay, so that's the advantage of using the gateway. It lets you get started with cloud or extend your storage into the cloud in a very simple manner, right? You can get going very quickly. There's no change required, no software change, right? Nothing to be no hardware change, right? So that's the benefit. All right. Okay. Rama, some questions in mod 2. Okay, I'll come back to that. Gajendra, while copying data from region 1 to region 2, how does local country data protection act is catered for? All right. So, if you can be more specific, that'll help, right? If you can be more specific, that'll help. Let me know. Let's say you have data in the US, you're moving into Europe, right? Let me know what exactly is the concern. That'll help. All right. But what you have to also know. Yeah. Okay. So EU, right? EU, I have some experience with this. So EU has this, EU data protection directive or policy or something like that, right? And this usually demands that your data be saved in a certain way, and it should be usually saved, somewhere in the EU region. Right? This is what this EU policy says, right? So what happens is AWS never copies data from one region to another. Okay. Now you might be saying this because I mentioned that AWS does automated copies, right? But all those copies are within one region. Okay. AWS does create copies. Okay, it does create copies of your data for data durability purposes, okay, but all within one region. Okay, so all the copies that AWS creates is all done within one region. It can easily do it, across multiple regions, but it doesn't do it, and it's precisely for these kinds of things. Okay, so it never copies data from one region to the other. All right, now you can do it. You can copy data from one region to another. Okay, maybe for DR, example for DR purposes, disaster recovery, business continuity purposes, right? But that's up to you. Okay, that's up to you. You're doing it, so you have to make sure that you are complying with all regulations. Okay, but AWS does not do that. Okay. And there's a follow-up question here, Jesse. What does a snapshot do? Same thing, right? A snapshot that's, let's say, of an EBS volume, right? Snapshot of an EBS volume. Later, we'll also look at a snapshot of an RDS instance, right? So these are basically, essentially a snapshot, right? It's a point in time a copy of your storage volume, right? And here the snapshot is usually stored within that same region. Okay, so snapshot is stored within the same region, right? Actually, the snapshot is stored in S3. Okay, so you may have a snapshot of an EBS volume. The snapshot is stored in S3, where it is very safe. Okay, it's very safe. Actually, the snapshot is much safer than the EBS volume. All right. So snapshot is stored in S3 in the same region. In the same region. Okay, never in another region. So a snapshot is actually a point in time copy of your storage volume. So a snap is point in time copy. All right. Okay. Next question. When we say storage, do we install databases on these physical devices? Yes. It depends, right? It depends on the type of the storage. So EBS volumes, right? EBS volumes especially are used with EC2 instances. Okay, only. I mean, you can't use EBS volumes in any other way. Okay, so they are used. They have to be used with EC2 instances. So let me reword this. So EBS volumes have to be used with EC2 instances, right? So if you're running a database, say Oracle, right, on an EC2 instance, right, then the data, also the software, is stored in the EBS volume. Okay, that's how it works. So when you install the database, you actually have to use the EC2 instance, but the installation and also the data later goes into the EBS volume. All right. Okay. Okay. So this question here, you tried creating the image and copied the snapshot from North Carolina to Mumbai. Am I doing it wrong? Yeah, it depends on what what's the purpose, right? Why did you copy it? So first of all, right, the army, okay, the army is slightly different from the EBS snapshot, right? Army is not the same as the EBS snapshot. Okay, so what happens is when you create an army, which is when you create an image, okay, so an army is backed by an EBS snapshot. So whenever you create an army, an EBS snapshot is also created, right? But remember, from an EBS snapshot, you can only create an EBS. You can only create an EBS volume. All right. From an army, you can you can create a server, an EC2 instance. Right. So they're slightly different, and it depends on what you're doing. So, for example, you may have set up, say, our WordPress server, right, in North Carolina, and then you create an army from that, right, and you want to set up that server in Mumbai. Okay, so then you copy the army, right? Don't copy the EBS snapshot. Copy the army into Mumbai, and then use that new army in Mumbai to create a new server. Okay, so if that's the use case, you should copy the army rather than the snapshot. Yeah. So S3. By the way, S3, right? If the snapshot in army, the snapshot is stored in S3, but within EC2 it doesn't say S3, right? You don't see S3 anywhere there. So just think about snapshot as a snapshot. Don't worry about S3, right? Yeah, so you have to copy the army if you want to create the server in the second region. All right, so this is about replication. I'll come back to this question later. Let's look at some other questions. So, Valen, I can install the Bitnami app in tier 0 to 4 storage. No. It doesn't work like that. No, not this way. Okay, the app, whatever the Bitnami app or any other app, has to be installed on EC2 instances. Okay, that's a server. The instance uses an EBS volume, one or more, right? It can use multiple EBS volumes as well for storage. Okay, so you don't install the app directly on storage. Okay, you don't install anything on EBS volumes, especially directly. Okay, all right. And S3 is a different type of storage. S3 is, you can't install any software on S3. Okay, you can't install software on S3. It's a place to store files, right? It's not a server on which you can run anything. All right, we'll see this. Let's wait a bit. Maybe this question is a little bit early. Let's wait a bit to see the demonstrations, and then hopefully you'll understand this better. Okay, Gajendra, is it mandatory to create an army before an instance can be created? No, I mean, look, some armies are already there, right? So you'll always have some armies, like say at the minimum you'll have the operating system armies, right? So an army, you can always create a server without creating your army. Okay, so you can create servers without creating your own armies. Okay, because armies are available already for different operating systems, different other stacks, right? So you don't have to create your own armies, okay? But to launch an instance, you need to have an army, some army, not necessarily your own, but some army has to be there, okay? Otherwise, how does the server know what software will be on the server, okay? So, yeah. All right. Sashi, storage content of S3 is independent of region for access. We have to modify policies accordingly. It depends on what exactly you're doing. Okay. Let's come back to this. Let's come back to this because we haven't spoken about S3 in detail, right? It's a bit early for this question. Let's come back to this. All right. How do we share the armies across different AWS user accounts? Can I apply some restriction on who all can access it? Yeah, so you can share it, right? Sharing is easy. Sharing is easy. So just from the menu, right? There'll be some menu option from the web console. Just select the army and share, right? And share. So you'll find some option there, and you can specify the account that you want to share it with. All right. Okay. Now, what restriction do you want? Okay, so what restriction do you want? Because it's just an army, right? You can only create a server from it. You can't do anything else with it. So if you're sharing an army, what restriction would you want? Okay, so what kind of restriction do you like? Would you want? Yeah. Okay. All right. Okay, folks. Let's. All right. So Rama, let me answer. Let me look at your questions. This is EC2. Okay, this is EC2. Let's look at some of these questions and get them out of the way, and then we'll go back to our storage services. Okay. So if you have a company, you have code, and you want to deploy it on 1,000 servers, in that case, how does develop, compute, storage, database, network, how do they work together synchronously? explain it with a bunch of tools in each service. No, I think, I think it's a bit early for this question, right? To be honest, it's a bit early because, we're just getting into individual services, right? And then later we'll see how all of this works together, okay? It's a little bit early, but let me briefly explain to you, right? So what happens is let's say you have a Java application, right? Or let's say you have a PHP application, okay? Which is what you want to deploy on 1,000 servers, right? So what you will do is these are normally, you'll have a web tier, you'll have an app tier, you'll have a database tier, right? This is how normally it is, okay? And all three can be on a single server, or it can be broken into multiple tiers, right? So here, let's say you have say 500 web servers, right? Let's say, and then in the app tier you have, let's say, another 500 app servers, okay, and then you have the database, right? So the way this works normally is this will be on EC2 instances, okay. All these 500 servers, each will be an EC2 instance, okay, and so will be the app tier. The 500 app servers will be 500 EC2 instances, okay. And the database tier, normally you can do it on EC2, but you can also do it on RDS, relational database service, right? And since you have 500 servers, you need to have a load balancer. So you need to have a web tier ELB sitting in front of the load balancers, all right? And then in front of the app servers also, you need a app tier ELB. Okay, this is broadly how you will do it, and then for security purposes, the whole thing, right? The whole thing will run in a VPC, right? So for security, these 1,000 servers, right, 1,000 or 1,000 odd servers, will run in a VPC. A VPC is a network. It's a network, a secure network, right? And broadly, this is how it is. Okay, broadly, this is how it is. Now, on the storage side, you have EC2 instances, and each instance will have its own EBS volume. Okay, so that's how the storage is linked to the servers. All right, and the database RDS also actually is built on top of EC2, and therefore this also uses EBS volumes for storage. Okay, so I hope you're beginning to see how all this is constructed, right, and how the compute and storage is linked. Basically, EC2 instances work with EBS volumes, right, and then the networking is available so that you can link the three tiers with each other. All right, okay. What else? Yeah, okay. Some of the other questions are EIP related. So Valen, Vivek, placement group is basically, you can look this up, right? Just look it up. It's basically a group of EC2 instances, a group of EC2 instances in the same AZ, okay? And they have fast network between each other. Okay, so any use case where you have a need for a cluster of servers with fast networking, that's where you can use a placement group. All right, free trial of AWS. In free trial AWS account, EIP is charging or not? I think it is charged. Look it up, right? So look up the free tier definition. Okay, my thought is it will be charged. I mean, anyways, EIP is free, right? EIP is free, even if you are not in the free tier, right? Even if you're not in the free tier, it's free, except when you don't use it, like someone has said here, right? If you don't use it, or rather, if you don't attach it or associate it with the server, then it's not free, right? Otherwise, it's free anyways. So don't be concerned about it. It's basically free. Okay, if you use EIP 1 year, if I use EIP 1 week, is the cost high or less? Yeah, so same thing. It doesn't matter, right? If you've attached the EIP, it's free. It doesn't matter how long. Okay, so length of time does not matter. Okay, as long as you associate to a server, right? Then it is free. Okay, if you don't associate, if you just keep an EIP and don't use it, then you will be charged on an hourly basis. So then 1 year will be more, of course. Okay, all right. Yeah. So yeah, these comments are the same thing, right? So these comments are right. So you can use the IP on any other instance, right? So you can use an EIP on another instance, right? But only one instance at a time, right? Only one instance at a time. Okay, so that's important. Yeah, so you have to do DNS registration. Yes, so before you use the DNS record sets, DNS registration is required. You can't create a dummy record. Okay, so you have to register a DNS, and no, it is hosted zone is set up quickly. Okay, so I don't think you have to wait. It is pretty quick. All right. Okay. And Rama, one more question is, how can we use developer tools? So which ones? Which developer tool? No, but again, if you name them, that will be better. Okay, because I'm just trying to see what right. So if you're more specific, that always helps. And I think like I said, it's a little bit early for this. All right, it's a little bit early for these types of questions. I know you want to see the big picture first, right? But I think it's better if you wait. Once we see all these services a bit in isolation, right? Then I think it's easier to sort of look at the bigger picture. Okay. All right. So code commit, like code commit, for example, code star is very new. I haven't looked at it, but code commit is basically a Git repository, right? Nothing to do with this. All right. So you set up your code, you sort of create your code in code commit, and then from your servers like this app servers, you can pull, right? You can pull from the Git repository, right? So code commit has nothing to do with this infrastructure. All right. Okay. Okay, folks. So let's leave this for a moment, right? And let's go back to storage. All right. So now we have had a brief introduction, right? And we've also had a good discussion. So you have some idea about these storage services, right? So we're talking about 5, right? So these 3: EBS, S3, Glacier, and then storage gateway and Snowball. So now let's get into each of these, right? We'll start with EBS. And then we'll go to S3. Okay, so these 2 are the most important services, and then we'll just discuss the other 3 services. But with EBS and S3, we'll take a look at some demonstrations. All right, so okay, let me go to EBS directly. Okay, so let's talk about EBS, right? This is the first of our 5 services. Okay. So EBS is a block storage, right? It's block storage. So it's very much like a hard disk, right? So you should think of hard disk volumes when you think of EBS, okay? But please note that it's not a real hard disk, okay? It's actually a network-based storage. So there's a network between the EC2 instance and the EBS volume, right? It's not a real hard disk, but it acts like a hard disk. Okay, it acts exactly like a hard disk. All right, and what is it used for? It's used like a hard disk. So it can be used for, say, if you have a database running on your server, then the data database is stored in the EBS volume. All right, and it sits in the upper tiers, right? Tier 0, tier 1, so it's fast. Okay, EBS volumes are fast enough for serious, very high input-output per second type of use cases, right? Oracle, for example, and other NoSQL databases, MongoDB. So all those things can be run on EC2 instances when you're using EBS volumes. All right. Okay. The other thing about EBS volumes is that the data will persist. Okay, so the data is safe when it is stored on EBS volumes, right? And your server may restart, for example, right? A server may restart, but the data on EBS volumes will not go anywhere, right? You restart your server, the data is there. You can access it again when the server comes up. Okay, so that's what EBS is. It's basically like a hard disk, but in reality, not a hard disk. And it behaves like a hard disk. It is used with the server. You can't access an EBS volume without an EC2 instance. All right, you have to sort of connect. You have to SSH to the server, and from the server, then you can sort of read and write into the EBS volume. All right. Then there's a snapshot. Okay. Then there's a snapshot. EBS volume has a snapshot. Okay. So a volume is like a hard disk, and a snapshot is like a backup. Okay. It's like a picture. You take a picture, right? You take a camera and you take a picture of your volume. So everything that is on the volume, right? All the data, all the configuration, all the software that is on the volume is copied into a snapshot, right? And like I said before, a snapshot is actually stored in S3, right? And S3, as we'll see later, is a very safe place, right? So a snapshot is actually very safe, right? And in fact, ironically, a snapshot is safer than the volume itself, okay? Because the EBS volume is like a hard disk, right? It can fail. EBS volumes can fail, right? And they are 20 times better. I mean, this may have changed recently, but what I have read before is that EBS volumes are 20 times more are safer, more durable, more robust than traditional hard disks. Okay, but they can still fail, right? EBS volumes can fail. But a snapshot is stored in S3, and S3 has very high durability. Okay, so a snapshot is very safe. Volume, not so much. Okay, so that's a bit ironic because a backup is safer than the volume itself, right? So that's how you have to look at snapshot. And especially if you're running databases, Oracle, MongoDB, those kinds of things, right, on your EC2 instances, then you need to have a regular snapshotting process. Okay, just like today outside of cloud, you may have database servers, right, and you always take a backup, right? Your databases are always backed up, and people normally run a nightly backup. Okay, so in the same way, with EBS volumes, you should have a snapshotting process where you snapshot your EBS volumes on a regular basis. Okay, all right. So that's a snapshot. Okay, so now we've looked at two things: a volume and a snapshot. Okay. Now this is a visual view, right? So you can see there's an EC2 instance, and remember there's an Ethernet communication, right? There's a network between the EC2 instance and the EBS volume. It's not a real hard disk. It's like a faux hard disk, right? And then you can have multiple EBS volumes. Okay, so one server need not have just one volume. You can have multiple EBS volumes, just like a regular server can have multiple hard disks, right? So you can have multiple hard disks. Same way, you can have multiple EBS volumes. And you can see here there are two. One is maybe a root volume, and then the other one is a second volume. Okay, and then at the bottom you can see there's a snapshot, right? A snapshot is a point-in-time view of your image of your EBS volume, right? And the snapshot is stored in S3 where it is very, very safe. Okay. The other thing about EBS volumes is that the volume stays within an availability zone, right? So if you have an EBS volume, you want to attach it to an EC2 instance, right? Then the instance has to be in the same availability zone, right? So the volume cannot be moved from one zone to another zone. Okay, so that's an important aspect, right? So if you have a volume and you want to attach it to a server, both have to be in the same availability zone. Okay, The other thing about EBS volumes is that it can only be used with EC2 instances, right? So if you want to read and write from the EBS volume, you have to sort of attach it to a server, right? Attach it to an EC2 instance. Then you can SSH or RDP into the instance, right? And then if you're writing a file, you can write that file into the EBS volume. Okay, so EBS volume cannot be used without an EC2 instance. All right. However, the EBS volume is a separate element, right? And it has its own life cycle, right? It has its own life cycle. It is not coupled to the instance in that sense. For example, the instance may be in a running state, or it could be in a stopped state, or you can also terminate the instance, right? EC2 instance can be terminated, but the EBS volume is a separate element, and it can remain even though the instance is not there, right? Or no matter what the state of the instance, right, running or stopped or terminated, right, the EBS volume is different, right? It's separate, and therefore, you can also detach an EBS volume from one server and attach it to another EBS volume as well. Okay, so these things are possible. Basically, the EBS volume is, although it's used with an EC2 instance, it is also separate, right? And it can be detached from an instance and attached to another one, right? And it is independent. Its own state is independent of the state of the EC2 instance. All right. Okay. Okay. Now these are some advanced capabilities. So there are some advanced capabilities. For example, you can encrypt your data that is stored in the EBS volume. Okay, so encryption normally is not required. Okay, if you trust AWS, you need not encrypt your data when it is stored in the EBS volumes. Okay, because if you trust the AWS security, your data is safe, right? However, some industries, some companies, right, may be very sensitive, right? So they might be thinking of risks where something could go wrong from the AWS side. Maybe a rogue AWS employee may look at your data, right? Or maybe some of the storage equipment, when they are being upgraded, right, the older equipment may go outside the AWS data centers, and the data may not have been wiped clean, right? It may get into the wrong hands. So there are some risks like that, right? So what you may want to do as part of your company policy, right, or as part of some regulations from your regulator, is that the requirement may be to encrypt the data and store. Okay, so you may say, look, I'm storing it with a third party. It's on the cloud. I want to be extra safe, so I want to encrypt the data when it is at what is called at rest. Okay, so when data is at rest in the storage volume, it should be encrypted. Okay, that may be some requirement you have. It's not mandatory, right? I think most people don't use encryption, but if you like, you can turn it on. Okay, so you can, it's just a flag. You have to say, yes, I want the data to be encrypted, and your data will be encrypted and saved, right? And you don't have to do much. Okay, you don't have to do much. It's transparent to you. Your application, when it writes into EBS, before it is written, it is encrypted and saved, right? And when you read, it is decrypted for you and given to you. Okay, so it's a feature that is available with EBS volumes. All right. Now this slide is very important. Okay, this slide is very important, and what you're seeing here is different types of EBS volumes. Okay, different types of EBS volumes. So what happens here is, you're seeing three. Actually, there are five now. This slide has become a little dated. There are actually 5 different types of EBS volumes. Okay. And what you should do is start with the one in the middle, the general purpose. Okay, whenever you see the word the phrase general purpose, that's what you should use. Okay, because that option will work in most cases. Okay, and the general purpose volume type is an SSD volume type, solid state device, which means it's fast. Okay, and it is a bit expensive. Okay, so it's fast and expensive, and you can see some performance characteristics of this volume. So, for example, it has a maximum IOPS, input output per second. Right, input output per second simply means the rate at which you can read and write. Okay, read and how fast it is, and the maximum performance is 10,000 IOPS. right? And also there's other aspects like throughput, etc. Okay, so this is what you would normally use for most cases, right? It says here development and test environments, but you can also use it for production environments, I think. Okay, but if you need something much faster, much better, it's a very serious. Let's say you're a larger company or a large, successful startup, and you have a very large scale internet service, maybe, right? Let's say Flipkart here in India, something like that, and you're looking for something serious, right? Something really fast, something really good. Then you can use this one here, provisioned IOPS. Okay, so this one is also SSD, but better. Okay, but better. So it has, you can see, higher performance characteristics, better throughput. It has better input output per second as well. Okay, and it's more expensive. It's more expensive than general purpose as well. Okay, so these two are the SSD volume types, and these two will be used as tier 0. Right? Remember our pyramid, the tier at the right at the top. So these two are normally used at tier 0. Okay, especially provisioned IOPS is tier 0 type of volume. Okay, most expensive but the best. All right, and then there's a general purpose, which is maybe tier 0, tier 1, and then you have one more option called magnetic here. Right, this is actually very slow. Okay, it's a very slow. It's an older technology, magnetic type of volumes, and it's very slow. But much cheaper. Okay, much cheaper. You can see it's half the cost, right? You can see this is this is 10 cents per GB month, and this one is half of that cost, right? So half the cost is very significant, right? And if you have something old, right, old data, old backups, maybe database backups, maybe, right, or some log files that you want to store safely, they are old. You don't access them frequently, right? So you don't care for performance, right? It doesn't matter how fast or slow it is. Right? What matters is that it should be cheap. Okay, so in those cases, you can use magnetic storage type as well, right? And here, actually, EBS this volume type actually would sit into tier 2 maybe, okay, or tier 2 or even tier 3, okay, even tier 3. So EBS is actually EBS has multiple volume types, and each type sits in can sit in different tiers in our pyramid. Right? So in that sense, EBS is a service which supports multiple tiers. All right. Okay. Okay. So here, when it comes to magnetic, there is a little bit of overlap with S3 and Glacier. Okay, because they're doing the same things at the same price point, right? In fact, this is cheaper. Magnetic is cheaper than Glacier and S3, but the EBS volumes have a size limitation, right? Whereas S3 has no size limitation. You can store as much as you want. Okay, so all right. So this is very important. This slide is very important. You have to understand that EBS volumes have different volume types, right? And you should know the difference between the volume types so that you can pick the right type for your use case, right? If you don't do that, then you'll have either you're probably using too expensive. If you select the volume type incorrectly, then you're using expensive storage for something that doesn't require that, right? Or you're using cheaper storage for a use case where you need performance, right? So you don't want to make that mistake, and therefore you should understand the volume types very carefully and use the appropriate volume type for your use case. All right. Okay. So this is EBS. Now let me show you a demonstration, and then we'll stop. We'll stop for some Q&A. Okay. So we'll stop for Q&A, but let me first show you a quick demonstration of EBS. All right. So here, what we're seeing is, what we want to see is how do we, create, or restore an EBS volume from a snapshot, right? This is the objective. But I'm also going to show you, first of all, how to create a snapshot from an EBS volume, right? And then from a snapshot, how do we create a volume? How do we restore a volume, right? So let's take a look at this. We'll also probably see how the EBS volume works with an EC2 instance, right? How an EC2 instance can have multiple EBS volumes. So we'll see a bunch of things, right, around this lab here. Okay. So from our web console, right, we'll go into EC2, because remember, EBS is not a separate service, right? It's a storage service, but it's only accessible, it can only be used from EC2 instances. Therefore, You won't find EBS under the storage category, right? Because it has to be used with EC2. So we have to go into the EC2 dashboard like we did yesterday. All right. So now here, yesterday we had created server, Linux server, Windows server, and so on, right? We'll do that again today, but before that, let's go to this section here, EBS, right? And you can see there are two options: volumes and snapshots, right? So we'll look at both of these, but first let us create a volume. Okay, let's create a volume. So this is an EBS volume, like a hard disk, right? Very much like a hard disk, and once we create a volume, we can attach it to a server, right? And then start using that volume. Okay, so before we create a volume, let's take a look at these options here, right? And you can see, first of all, the volume types, right? We saw 3 volume types in the slide, but like I said, there are actually 5 volume types now. And this is, the first one is what you should use by default, right? General purpose SSD. This is fast, right? And a bit expensive, but it's a good one for most use cases, right? If you need something faster, right, especially production environments, something serious, where you're looking for fast, you want to keep your customers happy, give them really fast database performance, application performance, then you can use this one, provisioned IOPS. Okay, all right. Then you have magnetic, which is like we discussed, the cheaper version, right? Very cheap but very slow. Okay, but very slow. And then these two we didn't see on the slide. These are newer options. This one is HDD. Both are HDD. Okay, traditional hard disk cheaper, right? And remember, a tier 1 type of performance, right? Tier 1, maybe tier 2 as well. And these are, SSD is tier 0, right? Tier 0 or tier 1. HDD is lower in the performance characteristic. But also remember that HDD volume types have better throughput. Okay, so SSD volume types have better IOPS performance, input output per second. Okay, so really fast, like databases, right? It reads, maybe you have thousands of transactions per second, right? So for those kinds of things, where you're reading and writing really fast, databases especially, you should use SSD. Okay, but some use cases don't need that kind of performance. They need faster throughput. Okay, throughput is the amount of data transferred per second. Okay, from your hard disk. So when you read and write, the data sizes are large, right? And you want those large data sizes to be written and read fast. Okay, so that's throughput, all right, which is different from IOPS. Right? So here the number of transactions has to be very fast, right? Here the amount of data has to flow fast. Okay, so throughput throughput applications could be Hadoop, for example, right? Big data type of applications will need higher throughput, whereas traditional databases like Oracle will need higher IOPS. All right. So depending on the use case, you have to choose the right volume type. Okay. All right. And also consider the tiers, right? So if you need tier 0, go for SSD. If you need something lower, go for HDD, right? For the lowest one, tier 3, or maybe tier 2, use magnetic. All right, so that's point number 1, very important, right? Okay, the next thing is the size of the EBS volume, right? So an EBS volume generally can have a minimum of 1 GB size and a maximum of 16 terabytes. That's huge, right? 16 terabytes. Okay, so I can have something like this, 16,000 GB, right? Or to be exact, 16,384. This is the maximum size of an EBS volume. That's a very big size, right? Don't create this because it'll be too expensive. Remember, the bigger the EBS volume, the more you have to pay. Okay, so what I'm going to do is I'm going to be very safe, and I'm going to create a volume of size 1 GB, the minimum. Okay, all right. Now, however, note that the performance of the EBS volume depends on the size of the EBS volume. Okay, that's something which may not be intuitive, right? You may not recognize that right away. But what happens with EBS is the bigger the EBS volume, the better the performance. So, for example, if I have a 1 GB size, right, the IOPS I can get is only 100. I can only get 100 input output per second performance from this EBS volume. All right. However, if I increase the size to say 100, right, you can see it increases to 300. right? So we get about 3 IOPS per GB. Okay, so for 100 GB size, we get 300 IOPS. I can increase this to 1,000, right? You can see it goes to 3,000, right? It goes to 3,000 and so on. Okay, so the bigger the EBS volume, the more input output per second you can get, right? So therefore, the size of the EBS volume depends A, on how much data you intend to store, right? Or how much data you expect to store, and B, what kind of performance you want, right? If you want faster IOPS or more IOPS, you have to increase the size of the volume, even though you may not be storing that much of data. All right, okay. So these are the major things here, right? And then also the zone. So an EBS volume is created in a specific zone, right? So if this volume is going to be in 1A, then the server to which this will be attached also has to be in 1A, right? One volume cannot be moved from one zone to the other, right? So you have to be careful, right? When you're creating volumes and servers, you have to make sure that they are in the same zone. All right, so let me create this volume. Okay, let me create this volume. Oops, I think I created a very big one, right? So let me delete that. This will be too expensive. Let me delete that, and let me create a new one. Yeah, so that's a mistake you can make, right? So let me go back and create a 1 GB volume. All right, so this is a volume, right? This is an EBS volume. All right, now, to use this, you have to attach it to a server, right? It doesn't make sense to have a volume like this. You can't do anything with it unless you attach it to a server. Okay, so that I'm going to show you. I'm going to show that to you shortly. Okay, before that, let's take a look at the snapshot, right? A snapshot is a point in time image of your EBS volume, right? It's like a backup. It has everything that was in the volume at the time at which you took the snapshot. Okay, so if I create a snapshot of this volume, right, I can say create snapshot, right, and let's call this my snap, something like this. You should normally have a timestamp with this so that you can recognize when the snapshot was created, right? So you can create a snapshot from a volume easily in this way, right? So this is a volume. Go into snapshot. You'll find there's a snapshot created here, right? Now this has been completed. The snapshot is complete because it's a very small volume, right? It took way less time because the volume is very small, right? If the volume was bigger, right, the snapshot would take time. It would take a bit of time to create the snapshot, right? So you can create as many snapshots as you like from a volume, right? And normally, especially if you have a database running right with this volume, then you'd probably have a nightly snapshotting process, right? So every night you'll have to create a snapshot of your EBS volume. Okay, just like you take a nightly backup of your databases, you can do a nightly snapshot of your EBS volume. Okay, and that's normally done in an automated fashion. You're not going to manually create a snapshot every day, right? You'll have to automate that. We'll talk about that later. The automation we'll talk about later. But what you have to understand is you can create many snapshots, right? Nightly snapshot, weekly snapshot, monthly snapshot, whatever you want, right? But you have to create a snapshot, especially for databases, right? Why? Because EBS volumes can fail, right? EBS volumes can fail. You must assume that it will fail. Therefore, you must have a snapshotting process. Okay, without a snapshotting process, you're running a big risk. Okay, all right. So now we have a volume and we have a snapshot, right? We've learned how to do both. Okay, we've learned how to do both. Now let's do a bit more. We have to understand how to use this volume, right? So we can only use this volume with an instance. So let me go ahead and create an instance, right? Let me go ahead and create an instance. And let's say we'll use this one, Ubuntu, right, which is what I am familiar with. You can use whatever you are familiar with, right? Let's use micro. It's covered under the free tier. And in the storage side, right, in step 4, okay, the server will have a root volume, right? It has to be created with a root volume, right? And the root volume means this volume will have the operating system and some other system software, right? If you install Apache, that'll go into the root volume, right? And you can also add additional volumes, right? You can add more EBS volumes if you like, okay, right here. But I'm not going to do it here. What I'm going to do is I'm going to create this server with a root volume, and later to this server attach the EBS volume we have already created, right? So you can attach EBS volumes at different times. So you can do it from here at the time of launching the instance, or you can attach the volume later as well once the server has been created, right? But remember, the server will always have a root volume, right? In addition to the root volume, you can attach more EBS volumes. Okay, in fact, that's a best practice. Okay, that's a best practice. You should have a root volume, and your data volume should be separate. Okay, your data volume should be separate, ideally, because this gives you some advantages. You know, let's say your server has failed. You want to fail over to another server, right? So you can simply detach the data volume and attach it to another server. Right? So this way, by separating your data volume from the root volume, you get some flexibility. Remember, the best practice is to have a root volume and a separate data volume. All right. So let's go ahead and create this server. Right. I'm just going to use something, an existing server, existing security group, or I'll use the default security group. This is a group which is very open, right? It allows everything. So I'm going to use this one for this server. So let's launch this, right? I'm going to use an existing key pair. I already have this key pair. So now we have a server, right? Now we have a server, right? And this server will work like it did yesterday, right? It has an EBS volume. We can connect to it, install our software, and so on. Okay, we can do that. But in this case, what we want to do today is to this server, we want to attach a new EBS volume, right? So let's see how to do that. Let me wait for this server to come up, right? Let's wait for this server to come up. Now it's in a running state. And now what I want to do is we have this additional volume, right? We have this volume. You can see there are two volumes now, right? The first one is the root volume, which came up along with the server, right? And the second volume is the one we created earlier, right? The 1 GB volume that we created earlier, right? And you can see the difference in the state, right? This one is available, which means it is not yet attached to a server, right? And this one is attached to a server, so it says in use. Okay, all right. So now let's say we want to attach this volume to the same server, right? So first of all, right, we have to make sure that the instance is in the same zone, right? So thankfully, right, this server has come up in the same zone. It's in 1A, right? And the volume also is in the same zone. So that's fine, thankfully, right? So now we can attach it. So I'm going to select this volume, and from the actions, I'm going to say attach volume, right? And we can pick our server, okay? And we can attach. Now remember, in Linux, right, this is there's something called a device name, right? So since we have two volumes, one root volume and one this one, right, we have to have different device names for each volume. Okay, so normally the root volume will have a name /dev/SDA, and then you can attach more volumes, and you can have names like /dev/SDB, SDC, SDE, and so on, right? So here the default name specified here is SDF, and we'll go with that, right? Let's go with that. That's not a problem. So this is the device name is used to uniquely identify each EBS volume, right? The hard disks, in traditional servers, right? When you attach multiple hard disks to a server, the same thing happens, right? So you can have different device names for different hard disks that are attached to a server. All right. So now we have an EBS volume that has been attached to that EC2 instance, right? And you can see, and now the state has changed to in use, right? It has changed to in use. If you go to the instance, by the way, right? If you go to the instance, you can now, if you look at the detail pane, you can now see there are two block devices, right? One SDA1, and this one is dev SDF, right? So this is the root volume, and this one is the 1 GB volume we have attached just now. Okay, all right. So we have now seen how to create an EBS volume, how to attach it to an EC2 instance as well, right? And we also saw before how to take a snapshot of an EBS volume. Okay, all this we've seen. Now remember, we have attached the EBS volume to the server, but that's not enough to use it. Okay, it's a block device, so it has to be formatted. right? So in the Linux world, we run a command called makefs, right, to create a file system on that EBS volume. Okay. In the Windows world, I think it's called formatting, right? So there'll be some command to format a hard disk, right, and then you can start using it, right? In Linux, you also have to mount the volume. Okay. So creating a file system, mounting the volume has to be done before you can use the EBS volume from that server. Okay, maybe we'll see that at some other time, right? But remember that attaching the volume to the server is not sufficient to start using it, right? You still need to format it, mount a, install a file system and mount it. Okay, so those things are done by a Linux administrator, right? You may be familiar with all this. If you're not, you can, in your team, you may have a server administrator, right? So those people will know what to do with the hard disk, right? So when you attach a hard disk to a server, you have to go and do something with it to make it usable, right? Same things have to be done with the EBS volume after you attach it to a server. All right, that's very important to note. Okay, so let's say now we have the server, right? We have the server. The server has two volumes, right? It has these two volumes, right? And also we have a snapshot of this particular volume, right? Let's say all our data is stored in this one, the 1 GB volume. Okay, so we have a snapshot which let's say we take it on a nightly basis, right? So we have a nightly snapshot that is available. Okay, so now let's say something goes wrong with your volume. Okay, so you have a server and this volume crashes, or there's some kind of hardware problem, right? Something happens with this volume and it's no longer functioning, right? It's no longer functioning. Okay, so what will you do? I'm sorry, not this volume, right? So let's say there's something wrong with this volume. It has crashed, and we need to do something to recover, right? So what can we do? What we do is we can create a new volume from this snapshot, right? So let's say this volume has gone bad, right? Let's say this volume has gone bad. So what I'm going to do is I'm going to sort of detach this, right? I'm going to detach this volume first. Let's detach it from the server. Okay, so I'm going to detach this volume from the server, and then I'm going to delete it. Okay, let's delete this volume as well, because there's some kind of hardware fault. Let's say, right, it's useless. We're not. It's useless to us any. Going forward. So I'm going to delete this as well once it detaches, right? And after that, I'm going to create. You can see it's now detached, right? It's now detached. So I'm going to delete this volume. Right, let's go ahead and delete this volume. It's no longer of any use to us. Okay, but what do we do? Our data has to be brought back, right? So what we do is we go back to a snapshot. Hopefully you have a snapshot taken in the previous night, right? And from this snapshot, you can restore the volume. Okay, so what I'm going to do is I'm going to say create volume from the snapshot. Okay, and we can also same things, or you can also at this time when you're restoring from a snapshot, you can do other things like changing the volume type, or you can increase the size of the volume. You can even change the zone if you are trying to bring up the server in a different zone, right? So those kinds of changes you can make, right? But in this case, let's say everything is the same. We just want the same kind of volume, and we are interested only in restoring the data, right? So we keep this at general purpose. We keep the size at 1 GB. And the server is in 1A, so we bring up this volume in the same zone, right? So we don't make any changes here. Everything is fine, and we create a new volume, right? So from a snapshot, now we have created a new volume, right? And you can see this is now available, right? And we can attach it to our server. Okay, the same server, we are attaching this new volume, right? In the same device name, okay? And we say attach. Okay, and now it is attached, and now you're back, right? Now you're back. You've recovered from a EBS volume failure. All right. Okay. So let me summarize the process, right? So you have an EC2 instance, and normally with the EC2 instance, you have a root volume and a separate volume where you will store your data, right? So normally you have to have two EBS volumes, right? And if you're storing some sensitive data in the EBS volume, for example, your database data, right, then you must have a snapshotting process, right? You must do it. Otherwise, you run the risk of EBS volume failure, and your data will be lost forever, right? A snapshot is very safe. Okay, you have to have a regular snapshotting process, nightly, maybe weekly, maybe, right? But once you take a snapshot, it is extremely safe. Your data is very safe, right? Okay, and then maybe you'll have some failure, right? Let's say one of your volume fails, right? Then you can go back to a snapshot which was the most recent snapshot, and from that snapshot you can create a volume or recreate the volume, right? And then attach the volume to the EC2 instance once again, right? And then you have recovered from the volume failure. All right, so all this we have seen. Okay, all this we have seen. And also, while creating the volume, remember we saw the volume type, right? There are 5 volume types. You must choose carefully, right? Also remember the size of the volume, right? It can be very small, it can be very large. Choose carefully depending on how much you need. Also, the performance of the volume depends on the size, right? So therefore, you have to think a bit about what size of EBS volume you want. Okay, all right. Okay, now let's do some Q&A. Okay, so let's do some Q&A, right? So, okay, so this one. Okay, so if EBS volume is attached, though it is terminated, no. So what happens is, look, if your EC2 instance, right? If your EC2 instance, you're basically stopping and starting, right? Why? Because let's say you have an EC2 instance with some software on it, and you use it today, then you have to use it next week, right? So there's a gap. There's a gap of 7 days, let us say, right? So what you're doing is you're stopping it and then starting it later, right? And what I suggested is you can instead terminate, right? Because you can create an army from it and recreate the server later, right? So that's what I was saying. Okay, so the EC2 instance can be terminated and you can recreate. So instead of this, right? Instead of this, create an army from your server, right? And create your server later from this army. This is better. This is better. Okay, it's cheaper. So this is cheaper. This is cheaper than stopping and starting. All right. Okay, this is what I was saying yesterday. Now, yeah. So I'm not sure. You can maybe rephrase your question, right? The EBS volume can be deleted along with the server, right? So when you terminate the EC2 instance, your EBS volume can also be terminated, right? But your data is safe in the army, right? So when the EC2 instance is terminated, the EBS volume can also be terminated at that time, right? Your data is safe in the army, right? So make sure that you create the army first, right? Then you can clean up, remove everything except the army, right? And then your data is safe. You can create a server anytime later. All right. Okay. Sarvanan, if EBS volume fails, can the data be recovered without using the snapshot? No, I mean, in general, look, if the EBS volume, like Rama here is saying, right, that it depends. Sometimes it depends on the type of failure, and there could be some options. But in general, if the volume is not accessible, right, if the volume is gone, if the volume has failed, it is not recoverable, right? Then how will you get the data without the snapshot, right? So then there is no way to get the data without the snapshot, right? Now, what's important is, why are you asking this question, right? What is in your mind? If you explain the use case, then it's better, right? But in general, if the volume has failed, you can't connect to it, then how will you get the data, right? It's only in the snapshot that you can keep the data safe, right? There are some other options. There are some options like you can have a replication and all that. So you can do. There are some other options. Now you might be thinking, for example, that snapshot is old, right? The snapshot will be as of last night. The failure happens at say 11 a.m. in the morning. So a lot of hours have passed after the snapshot. So some of your data may be lost, right? So that is true. That is true. Okay. So you can then consider replication, right? Database replication, especially. So you can have, two instances, right? Two instances, two EC2 instances, one primary, one secondary, right? With DB replication. So here, of course, you can recover because you have a second server on which your data is safe, right? But otherwise, no, you need a snapshot. All right. Okay. Okay, Rama, what is encryption and snapshot ID in creating the volume page? Encryption is, you can turn on encryption, right? You can encryption, like we discussed in the slide, yes or no, right? Do you want encryption or not? Okay, that's it. That's it. That's nothing much to it. It will transparently encrypt and store the data for you. Okay, so that's one. And snapshot ID, if you're creating the volume from a snapshot, right? If you're creating a volume from a snapshot, you can specify that ID, the snapshot ID. Okay, how often the snapshot will create? That's up to you. That is up to you. Okay, so how often do you want to create a snapshot? So normally for databases, right, you should do a nightly snapshot. Okay, for others, let's say app server, you can do a weekly or a monthly snapshot. That's fine, right? But normally for a database, definitely a nightly snapshot. Okay, what do I have to do if I want to create a snapshot every 1 hour? Yeah, you can automate it, right? But then, first of all, why do you want that, right? So why do you want an hourly snapshot? That's very important to understand, okay? Because the hourly snapshot may not be the best option, okay? It may not be the best option. So you can, let us know why do you want the hourly snapshot. But if you really need it, you can automate that, like this person here, this comment here says, you can automate it using a CLI based script, okay? Or you can create a Lambda script which can do it, right? But first of all, this doesn't sound like a good solution, okay? An hourly snapshot does not sound like a good solution because remember, when you take a snapshot, right, your server freezes, right? Server freezes when snapshot is taken, right? This you may not have realized, okay? So your users may complain if you take an hourly snapshot, right? That's why even in databases, right, we don't take hourly database backups, okay? That's because the database backup procedure or snapshot procedure can disrupt your application, okay? So you don't do an hourly snapshot normally, right? And there are other solutions we can discuss if you explain why you want an hourly snapshot. Okay, Chandra, if I create an army from an EC2 instance, will it contain root plus additional volumes? Yeah, yes, you can, yes. Okay, so you can do that. All right, next question. For example, if I'm using a banking application, for that I have to take a backup for every transaction. How can I do this? No. So you want to take a backup for every transaction. So what do you do today outside of cloud? You don't take hourly snapshots. Okay, that's not a good practice. Okay, what you can do is database replication. This is okay. Okay, database replication is what is normally used, right? So you have a secondary server into which you replicate your data. This is fine. This is fine, right? And we'll talk about this in RDS. Okay, relational database service. So here there are many options where without too much of DBA skills, right? You can have database replication. You can have replication. You can also have read replication, read replicas created, Okay, lots of options are there with RDS, right? If you don't want to use RDS, you can set up your database in EC2, but then you have to manage replication yourself, right? So so all database engines, Oracle, SQL Server, MySQL, they all support database replication, right? So here you have a second server, a secondary server, right? And you have a master slave configuration, and the slave server will have all the transactions. Okay, all right, this is what you have to do. All right, so basically an hourly snapshot is not a good practice. Okay, next one, Shyam, frequency of taking up EBS snapshot is the responsibility of AWS account holder. Yes, of course. Yes, you have to take snapshots, all right, because you know your application, right? AWS doesn't know anything about what you're doing. Okay, so it's your responsibility. Okay, so are there any cron jobs that we can trigger every 1 hour? Is there any inbuilt util in AWS for the same? Yeah, I mean, you can use Lambda. Okay, you can use a Lambda function for this, right? Or you can run a cron job on some server. Right? Many ways of doing this, but Lambda I think is best. Okay, Lambda is a better option than running a cron job. We'll talk about Lambda later, right? We'll be talking about Lambda, and I'm going to show you exactly this use case. Okay, so in my demonstration plan for Lambda, I have a use case where we have a function, Lambda function, which will take a snapshot on a regular basis. Okay, so this is coming up. All right, Gajendra, your instance was created in AZ1A, however, volume was created in AZ1C, both in the same region. So can we define where to create it to ensure they are in the same AZ? Yes. Yes. So when launching an instance, okay, or when creating an EBS volume, right, in both cases, you can select a specific AZ. All right. If you don't select an AZ, then AWS will choose it for you, right? But if you like, just for this purpose, you can make sure that your server and the volume are coming up in the same zone. All right. If you can leave it alone, then it comes up in a default AZ. Okay, Subani, can we say root devices are ephemeral storage? No, not necessarily. Okay, not necessarily. So you know about ephemeral storage, but for the rest of the group, right? What you have to know is there's a bit of history. So before EBS, right? EBS came later on the scene, but before EBS, there used to be, and it is still there. Okay, there used to be something called this one, ephemeral storage. Okay, these are actually real hard disks attached to a server. Okay, and when you restarted a server, the physical host changed. So the you don't have access to the old hard disks. Okay, so data used to get lost. So data would be lost when server was restarted. Okay, so and then EBS came, and EBS was for persistence, right? So EBS solved this problem because it is persistent, right? You can persist data on EBS. Okay, so there's a bit of history here. So EBS root volumes need not be ephemeral storage. So when you launch an EC2 instance, you can choose the root volume to be EBS or what I call instant store or ephemeral. Okay, so it's not necessary that the root volume is ephemeral, although it can be. Okay, so you can use both. Your server can be of the EBS type, EBS storage type, or of the instant store type, right? EBS is slightly more expensive. Instant storage is free, by the way. Okay, so you might want to look at this, especially for, say, web servers, app servers, that kind of thing, right? Where you're not storing anything of value. Okay, but for databases, if you're running Oracle or something like that, you have to have an EBS storage. Okay, so you can choose this. This is, I didn't cover this because most people go with EBS nowadays, right? But what you have to know is there are two types of storage options available. One is ephemeral and the other is persistent. EBS being the persistent option. All right, okay, let's do these other questions, right? And then we'll finish up today's session, and tomorrow we'll look at S3 in the first hour, right? And then we have to look at the other 3 services in the next hour. Okay, we're running a little bit late, but okay, anyways. So let's look at these 3 questions. So are there any charges applicable for taking snapshot? Does it depend on the number of snapshots? Yes, yes, of course, you have to pay for everything, okay? So you have to pay for all types of resources, right? And resources, because you know it is a snapshot is something which takes up storage, right? So a snapshot is storage. You have to pay for it. Okay, you have to pay for it. All right, and yes, it also depends on number of snapshots, right? The more you have, the more snaps you have, the more you pay. Okay, the more you pay. So what you can do is you can have a nightly snapshot, right? And then you can have a retention period. So you know, let's say you can delete older snapshots after 6 months or 1 month or whatever you have, right? So you normally clean up. So you should clean up. You should have a cleanup process. Okay, you should have a cleanup process to delete older snaps. Okay, so you know, just like you have backup process, right? You delete old backups so to free up space. So same kind of thing applies here. Yeah, even the armies. Okay, even the army. So the army is backed by a snapshot. Okay, by a snapshot. So it's the same thing. So army costs are the same as snapshot. All right. Can we detach root volume from one instance and attach it to another? Yes, you can. You can. Yes. Okay. So you have to stop the server. What you may have to do is stop the server and detach. Okay. You can do it. And by the way, when you attach it to another instance, you have to remove that root instance from the second server, right? Before attaching this one. So so you can do it, but you know, why? Why? The question is, you know, why? What's the use case here? Right? What is the use case? That's a issue. Okay, Sashi, after attaching EBS, can we distinguish installed software other than from root? No, it's not clear. Okay, the question is not clear. After attaching an EBS volume, can we distinguish installed software? Yeah, no, so normally what happens is the software is on your root volume, right? All software is on the root volume normally. Okay, so there's no need to separate that. Okay, in the second volume, the second volume is usually the data volume. Okay, the second volume is the data volume. This is where your data goes. Okay, so you have to do some configuration to make sure the data is written into the data volume, but the software is usually on all the software, right, is usually on the root volume. All right, okay, and for the current learning, you have created an army. Is that going to be charged? Should I go and delete it? Yes. Okay, it will be charged. It will be charged. Look up the free tier, right? So from what I remember, free tier covers 1 GB of snapshot. Okay, 1 GB month of snapshot. So your army is probably using up an 8 GB snapshot. Okay, so which means you will exceed the free tier threshold. Okay, so that's why you will be billed. You can expect a little bit of cost. It's not expensive. Okay, it's not expensive, but you should delete it if you're not using it. Okay, all right. So okay, so this one here, I think no is a root volume instance not integral part of server. No. So here, no, the EBS volume, even if root, is independent. Okay, it's independent. Like we said in the slide, right? It's independent of the server. It can have its own separate life cycle. All right. Okay, folks. So I think we are out of time, and it's also good. You know, we've had a good discussion on EBS. We've seen some demonstrations as well, right? So I hope it's clear. And tomorrow we'll continue with the rest of the module, right? We'll look at S3, which is as important, right? It's as important as EBS. Okay. All right. Okay, folks. So let's end this session. I think there are some follow-up questions. I'll give you a response in a written fashion later. All right. So let's end the session. I'll see you tomorrow, and have a good night. Bye.